Hi, grade 11. Today we are going to study differentiation or the first derivative. Part 1. Differentiation or derivative. 2 points. Basic rules of differentiation and the product and quotient rules. Our objective is the basic rules of differentiation. The objectives are 8 points. Derivative of constant, power rule, derivative of a constant multiple function, the sum rule, the first derivative of product of two or more functions, the first derivative of quotient of two functions, the first derivative of composed functions, chain rule, at the end, derivative of trigonometric functions. First, let's understand the meaning of derivative. Derivative is the slope. Derivative same as slope. And if the derivative of a function is its slope, then for a constant function, derivative must be 0. And that is the rule number 1. Rule number 1, derivative of a constant. And we will use the notation d over dx, fx. How to read? Derivative of the function fx with respect to x. Or, instead of d over dx, we can use f dash x. Same meaning, different forms, the same meaning, which is derivative of function. To mean the derivative of f with respect to x at x. How to read? But the rule number 1, derivative of a constant, derivative f dash x equal 0. Okay? Geometrically way, the derivative of a constant must be 0. Why? Because the graph of any straight line, a straight line parallel x-axis, is called a constant function and its slope is 0. We studied before. In a straight line, horizontal straight line parallel x-axis has a slope 0. Second rule, the rule of power. The power rule. If n is any real number, then derivative n up to x up to power n with respect to x is n x up to power n minus 1. How are we going to find the derivative? The exponent n drop to be a coefficient and then decrease the exponent by 1, n minus 1. Okay? I can rewrite as f dash x equal n x up to power x n minus 1. For example, if I have fx equal x, then what is the derivative? Look, f dash x or d derivative x with respect to x is 1 multiply x up to power 1 minus 1. What this? That one is the coefficient, is the exponent of x. Drop it to be a coefficient and then decrease the exponent 1 minus 1. You have x power 0, which is 1. Another example, I have fx equal x power 8. Then the derivative f dash x equal d derivative x power 8 with respect to x. 8, drop the exponent to be coefficient and then take 1 from the original exponent, 8 minus 1. So the final answer is 8x power 7. Another one, if I have fx equal x up to power 5 over 2, then f dash or derivative of the function x up to power 5 over 2, I'm going to drop the exponent to be coefficient and take 1 from the original exponent. Final answer, 5 over 2x up to power 3 over 2. Another example, find the derivative of fx equals square root x. You know that how to rewrite square root x? Do you remember? Let's see. Square root x is x up to power half. Yes. The inner power divide the outer power. 1 divide 2. X power half. How to find the derivative? Drop the exponent to be a coefficient and take 1 from the original exponent. 1 over 2 minus 1. So the final answer is 1 over 2 multiply x up to power negative 1 over 2. Who can tell me how to ignore the negative beside before half? Yes, drop. Flip the x to be down and then rewrite half as a power square root x. يبقى 1 over 2 square root x. Another example, find the derivative of fx equal 1 over cubic root x. Yes, cubic root. Yes, cubic root. How to convert, how to ignore the cubic root. Convert to be what? Let's see. It's x up to power 1 over 3, but 1 over 3 down. Flip to be negative 1 over 3. Derivative. I'm going to drop the exponent to be a coefficient and then decrease it by 1. Negative 1 over 3 minus 1, which is negative 4 over 3. And the final, negative 1 over 3x up to power 4 over 3. 4 over 3 down positive because it was up negative. Now, let's study rule number 3. Derivative of a constant multiple function. I have two parts, constant and a function. Let's see. As here, C, if C is any constant real number, then derivative C multiply the function fx with respect to x. I'm going to separate between, isolate C, and then find the derivative of the function fx. How come? Let's solve that example. Find the derivative of fx equal 5x power 3. Here we have two parts. I have a constant multiply a function or a variable x power 3. I'm going to isolate it 5 and x power 3. 5 and then derivative of x power 3. As we studied before, I'm going to drop the exponent to be a coefficient and decrease it by 1. What about the 5? Keep it as it is. So it's 5 multiply 3x power 2. Remove the brackets. The final answer 15x squared. Another one. Find the derivative of fx equal 3 over root x. f dash x, or the derivative of 3x up to power negative 1 over 2. From where we get negative 1 over 2? From the square root. Square root rewrite as a fraction 1 over 2. But down, positive, up, it's negative. Now, the constant as it is. And then derivative of x up to power negative half, drop negative half to be a coefficient, and decrease 1 from negative half is negative 3 over 2. 3 over 2, to ignore the negative, flip the fraction to be up, it's negative 3, and down 2x up to power 3 over 2. Rule number 4 is the sum rule. The sum rule, I mean, if I have two terms or two functions, between them positive or negative. Whatever sign you have, addition or whatever operation you have, I'm going to find the derivative of first function and then derivative of second function. Okay, يبقى separate between fx and gx. Calculate the derivative of the first x and then plus or minus derivative of gx. Example, find the derivative of fx equal 4x power 5, 3x power 4 minus 8x squared plus x plus 3. As I said before, I'm going to find the derivative of each term alone. If I have a constant multiply a function as 4 multiply x power 5, I'm going to drop the 4 because it's a constant and then multiply it by derivative of x power 5. Let's see. Here, derivative, the expression with respect to x, d over dx or f dash x. First step, isolate the constant and x power 5. Isolate 3 and then x power 4. Negative 8 and x power 2. 3x and 3 as a constant. First term, 4, it's going to be 4 multiply what? Yes, 5x power 4 and so on. 4, 5x power 4, 3, 4x power 3, negative 8, multiply 2x plus 1, derivative of x it's 1, derivative of 3 is 0. And then remove the brackets, let's remove the brackets, 4 times 5, 20, 3 times 4, 12, negative 8 times 2, negative 16, and 1 plus 0, it's 1. Another example, I have example, find the derivative of gt equal t square over 5 plus 5 over t power 3. G dash t or derivative of the expression t square over 5 plus 5 over t power 3. I'm going to find, what happened? Yes, separate between the coefficient and the variable. Coefficient and the variable. The coefficient here is 1 over 5 multiply t square. And here I have a coefficient 5. And what's about t power 3? Take it up by negative exponent. Now, as we studied before, isolate 1 over 5 and then derivative of t square. Isolated 5 and then derivative of t power negative 3. Okay? 1 over 5 multiply derivative t square is 2t plus 5 derivative t power negative 3 is negative 3 t power negative 4. And remove the brackets. It's going to be 2t over 5 minus negative 15 over t power negative 4 is going to be t up to power positive 4 but down. Final answer, outcome, multiply 5 multiply t power 4 and t power 4 multiply 2t and L5 times L15. 5 times t power 4, 5 t power 4, t power 4 times 2t, 2t power 5, 5 times 15, it's 75. Now let's summary what we said in that video. First, derivative of a constant. For example, if I have a function fx equal 5, 5 is a constant number, then the derivative equal 0. Second point, our second case, L power rule. Fx equal x power 3 and the derivative, then the derivative equal 3x squared. Drop the exponent to be a coefficient and then decrease the exponent by 1. Derivative of a constant multiple function. Isolate the exponent, the constant, and then calculate the derivative of the x power 4. Okay? Sorry, في هنا mistake. دي المفروض supposed to be x power 4. Now, let's multiply the 5 and derivative of x power 4 is 4x power 3. It's going to be 20x power 3. Now, repeat the video and listen carefully. Try to do next two exercises by yourself. Find the first derivative of each of the following. The first, if x equal x power 4 minus 2x power 3 plus 5x minus 12. And second exercise, if x equal 8 minus negative 2 over 3x power 3 plus 1 over 5x power 5. And we will discuss your answers next conference, inshallah. Your homework in booklet, page 71, 72, and 73. You have to send your answers using LMS or my mail. Good luck, grade 11. Please do your homework. Study hard. Stay home, stay safe. Good luck.